Hello students, so today we are going to perform our 8th experiment. Okay, so this experiment is for construction of voltage multiplier circuits, okay, like doublers, triplers, quadruple, etc. Okay, so we are moving till quadruple only. Okay, we will verify the output at the end also. Okay, so what is voltage multiplier? It is an electronic circuit that delivers the output voltage, okay, whose amplitude or peak value is 2, 3 or more times greater than the peak value of the input voltage. Okay, so this is our circuit. You can look here. Okay, so these are for doubler, tripler and quadruple output. Okay, so we have made that thing in the same circuit. Okay, so in this thing what happens now, the capacitor is giving the main role here. Okay, it charges and discharges so that the output becomes twice, thrice, etc. Okay, so this is the theory simply which I have written here. So let me explain you the actual working here. Okay, so this is the circuit diagram here. Okay, suppose I am giving a 6 volt of AC signal here. Okay, so this is RMS. Okay, so you could find out the value of the peak to peak value, whatever it is. Okay, suppose value of the voltage is Vmax here. Okay, Vm. Okay, Vmax or Vm. Suppose I am writing here Vm. Okay, Vm peak to peak value is there. Okay, so firstly we will talk about the doubler output. Okay, how to get the double output of this one. So here I am using a 10 microfarad capacitor so that it could hold a large amount of charge here. So now what happens when this end, okay, this end gets the positive supply. In that point, this D1 diode, okay, so this D1 diode is in forward bias condition. So in that case, what happens? This capacitor charges C1. Understood? So this C1 charges to the peak most value of whatever the voltage here. Since I have chosen here Vm, so it capacitor charges to Vm voltage. Okay, so now this was for first half cycle. Okay, now for first half cycle also one thing happens. Okay, this D2, okay, so this D2 here is in reverse bias condition. Okay, remember this thing. So since this D2 is in reverse bias condition, so that's why this C2 capacitor is not being charged here. Okay, now coming on the point, what happens when this point get negative voltage and this point get positive voltage? That means that in the second half of the cycle, that means in the negative half of the cycle. So what happens in the negative half? This D2 becomes in forward condition. This D2 diode comes in forward condition case, and when this thing comes in forward bias condition case, this C2 starts to charge. Okay, why? Because this one is not charging now, because this one is in currently in reverse bias condition. Now this C2 is charged. C2 is charged to the maximum value of the voltage which it is providing here, that is Vm only. Okay, now C2 is charged to Vm because of this diode acting as a forward bias condition. Now since this diode is in reverse bias condition, so it will not allow this C1 to charge. So this C1 will discharge. So now when this C1 will discharge, so the value of voltage, okay, which was present there, that is Vm, that will pass to this C2. Okay, and when this will pass to C2, since C2 was already charged to Vm because of this diode being forward biased, it again charged to plus Vm. Okay, Vm plus Vm, that is 2Vm. It is charged to 2Vm. Okay, suppose I am going to write it here. Just see here in the notepad, I am going to write here. So what happens now? For this C2, what happens? This C2 firstly becomes Vm. Okay, voltage max, which I have chosen. Okay, why? Because of diode to in forward bias condition. Okay, now what also happened, since C1 is not charging in this point, so what happened, it discharges. So when it discharges, it will give it Vm, okay, up to which it has been charged to this C2. So this C1, what it will do, this will transfer, okay, transfer its Vm charge to C2. Understood? This will happen. So now C2 would be again charged. So the net charge in C2 would be Vm, okay, plus Vm, that is equal to twice Vm, that is twice voltage max. Okay, okay, this should be in capital letter. Okay, so no issue. Okay, you understood now this thing. This one is Vm. Okay, so fine. So this capacitor C2 becomes twice Vm of voltage it is holding now. So when you will take the output from these 2 points, you will get twice Vm charge. Okay, that means since Vm was present there, but I am getting a double voltage from these 2 points. Okay, so this is how this circuit part from this to this is acting as a voltage doubler circuit. Okay, so now we will talk about the tripler one. The tripler. So now how from this point to this point I am going to get a tripler output. Okay, so up to this point I think you have understood. Okay, so this one from this to this was of one positive cycle and one negative cycle of the input. Okay, this one was for first positive, okay, half cycle, sorry, first positive half cycle of the input, and similarly the second one is the first negative half cycle here. Okay, so just check here, this thing had happened. Okay, now we'll talk about that what happens in the second positive half cycle. When the second positive half cycle comes here, what happens, since this D2 and this D4 are currently in reverse bias condition, okay, this D3 becomes in forward bias condition. Now one thing is there, I'm not saying that this D1 is coming in forward bias condition. Why? This D1 should be also in forward bias condition? No. What is the reason that this D1 is not coming in forward bias condition? The reason is that this voltage, which is across this capacitor, okay, it is 2 Vm, okay, and we are getting Vm only here. From here we are getting Vm, and here the voltage is 2 Vm. So you can see that the point A is in negative, or we can say this point A is negative with respect to point B, because the voltage here is 2 Vm and here it is Vm. So that means that this diode is in reverse bias condition. Okay, so for second positive half cycle also, this D1 diode doesn't come in the forward bias condition. Okay, because this 2 Vm charge, it is not allowing this D1 diode to comes in forward bias condition. Understood? So this happened in this thing. Now in this thing you have seen, I have already said you that this D3 comes in positive forward bias condition. So what happens, this D3 comes in forward bias condition, so we will see a charge here. Okay, so what type of charge we are going to see is, we are seeing that this C2, it discharges. Okay, as it is not getting any charge here, so it discharges, and this charge will appear here at the point C3. Okay, so C3 will become 2 Vm, okay, as C2 discharges. Okay, sorry, as C2 discharges, so this C3 would become 2 Vm. Understood? So now what actually happens now here, I'm going to say this, that C3 has become 2 Vm. Okay, it is holding now 2 Vm of charge. Okay, so now when you are uh, taking the output from this point to this point, okay, we are getting the charge of C1 and C3. Okay, so currently C1 is holding Vm charge, okay, and C3 is having 2 Vm. So if we are getting if we will take the output from this point to this point, what we will get? We will get the Vm charge from this one and 2 Vm charge from this one. Okay, so the net of charge would be Vm plus 2 Vm. Okay, so the net of charge would be 3 Vm. Okay, so this would be the whole amount of charge, okay, which we will get from this point to this point. Charge means to say here voltage. Okay, so it will give us a 3 times voltage, okay, which we are giving this circuit as a input supply. Okay, so we have seen that for the second half cycle this C3 is becoming twice of Vm charged. Okay, now since twice of voltage max charge is running here, okay, so we will move on to the quadruple output. Okay, so now what happens for the quadruple output here? Okay, we will talk about the second negative cycle now. Okay, we have talked about second half cycle, positive half cycle. No, so now we will talk about the second negative half cycle. So what happened in the second negative half cycle, I am going to tell you. So when the second negative half cycle comes here, this D2, okay, and this D4 both comes in forward bias condition, but this D1 and D3 are in reverse bias condition at this point of time. So what happens at this point of time? This C3 will discharge, okay, the C3 will discharge and this charge will now appear at this C4. Okay, so we can write here that C4 has become twice of Vm. Okay, why? As C3 discharges. Okay, so this has happened in the second negative half cycle. Okay, so we have seen that this point is getting twice of Vm charge. Now here look here, in this negative half cycle what happens now? This C2, okay, this C2 is currently having twice of voltage max. Okay, just I have seen, just look at here, in the first negative half cycle what happens? This 2 Vm of charge was present in this C2. So in the second negative half cycle also, since this is a negative cycle only, so this will be having a 2 Vm of charge. Okay, and this is currently now also having a 2 Vm of charge. So what happens if we will take an output from this point to this point? Both of the 2 Vm and 2 Vm will add itself and it will give us a 4 Vm of charge. Okay, so a 4 Vm of charge will be get at output when we will take the output from this point to this point in the second negative half cycle. Okay, and this process will continue and continue and continue, and this will give us doubler output, tripler output, quadruple output. Okay, and if we will extend this circuit, it will give us a more of this type. Okay, we can multiply the output voltages by use of capacitor and the diode. Okay, so this is how this circuit is going to work. Okay, so now what I am going to do, I am going to draw the circuit and I will show you that how this thing works in multisim. Okay, so just I am going to open this multisim here. Okay, so in multisim, firstly what I am going to do, I am going to add a power source here, a ground here. So I am going to take an AC voltage source here. I am then going to add a ground here. Okay, so these two things I have taken, and now I am going to take the diode 1N4007. Okay, the source all group. So in this thing I am going to search for N14007. Okay, so I have got this thing. So I will use 4 diode here, one here, one here, the third one here, and the fourth one here. Okay, so this thing I have taken. Now I am going to take the 10 microfarad capacitor. So from the basic I am going to take the capacitor of 10 microfarad. Okay. One 10 microfarad here, one here, and one here. Okay, so now I'm going to close this one and I'm going to join the whole of the circuit. Okay, so I'm going to need one more capacitor here, so I'm going to copy paste this thing here. This I have joined. Okay, this I have joined. Now what I'm going to do, I'm going to rotate this one. Okay, so for that part I'm going to rotate this clockwise. Okay, so just see here, I have done this part. Okay, and this thing I will rotate counterclockwise. This should be here. Okay, fine. Okay, this one is running better. This thing is now okay, and now I'm going to use this capacitor here only. This diode I am going to rotate here clockwise. And this diode I am going to rotate counterclockwise or anti-clockwise. Okay, so just see here, I have drawn the circuit here. Okay, so I do need to do 2 to 3 things here. Firstly, I am going to join this one. Okay, I am going to draw the ground from this to this point. Okay, so I do need to connect this connection also. Okay, fine, and I do also need to connect this point also. Okay, so this thing I have done. Okay, so here 1 volt peak to peak is written. Suppose I am going to write here 5 volt peak to peak. Okay, so we are going for peak to peak only here. Okay, don't take the value of RMS. Okay, it is not required here. Okay, so now for quadruple, tripler, and for doubler, we are going to use 3 multimeters here, so that we can check the output here. This is the first multimeter. Here I am going to connect from this part to this part. Okay, it looks good. Okay, so this will act as a tripler. Okay, this will measure the tripler one. Okay, so now for the doubler one, what I am going to do is I am going to add it across this thing. Okay, positive one here and the negative one I am going to add it here. Okay, so this will measure the doubler one, and for quadruple one I am going to add a multimeter again here. Okay, so in this part what I am going to do is I am going to just connect it. Okay, it moved a little bit down here, and the final part of this thing I am going to connect it here. Okay, fine. So this is my whole of the circuit which I have connected. Just see here, I have taken 3 multimeters also. So now what I am going to do, I am going to run it So this one would be my tripler, this one would be my doubler, and this one would be my quadruple. Okay, so just see, I have run it. So voltage DC is already chosen here, so it's fine. Okay, so just see here, I have used here a 5 volt peak to peak. So theoretically the doubler would be giving here a 10 volt peak to peak. So here I am getting the average voltage here, since I have used the multimeter here. Okay, so it is around 9.42 or 43 volt. Okay, here this one is giving quadruple value of around 14.16, and here this one it is giving the quadruple value of around 18.9, that is around 19 volt. Okay, so now some little bit information about here. One thing is here that since diode are here, so we are getting some voltage drop. Okay, so we will get some voltage drop necessarily here. Okay, first thing. Second thing is there that these kind of circuits we use when we are needing DC supply in a huge amount. Okay, we are giving here AC source, remember this thing. Okay, and then we are getting here the DC one. Okay, so this type of circuit is also working as an AC to DC circuit converter. Okay, so this is, you can see here the output here. Okay, okay, you can analyze this thing. Okay, and here already I have told you the theory that how actually this works. So this thing I haven't written here. So this thing has worked 1 second negative half cycle. Okay, negative half cycle. Okay, so this thing has worked for second negative half cycle, which I haven't written here. Okay, so I think you have already learned the theory about this thing. Okay, I will also write the detail of this thing in this manual also. Okay, I will make the manual of a better kind. Okay, and I will provide it to you. And remember what you have to do, you have to write the result here, the conclusion, the precautions here in the observation, what you have seen, that what should be the theoretical output voltage, what should be the practical output voltage. Okay, you have to write those kind of thing there, understood? And you have to take the screenshot of this one also. Okay, so just keep it here. Okay, so I have taken here a 5 volt peak to peak value. Okay, so just take another value of voltage here. Okay, just don't copy mine. Okay, just use your own multisim to draw this circuit. Okay, and choose here different voltage. Okay, and you will get the possible